Nice to see so many people here. My name is Gunnar Peipmann. I am one of ASP.NET MVPs. Most of people perhaps know me because of my blog. And most of materials shown here are also available in my blog. I'm using it like a brain extension. If I work out something, then I write it down. So when I have to come back, then I have solutions already saved. And as a kind guy, of course, I share it. I share my achievements with everybody else. Today, first presentation by me is about the Vision API of Azure Cognitive Services. The materials for this presentation are already available in internet. A demo application is in GitHub, so you can use these same URLs to get the working code. All you need by yourself is some Azure account, because you need some keys for cognitive services. Okay. Actually, Azure Cognitive Services is a bigger family of intelligence services than just vision. There are also speech-related services, language, knowledge, and the search. We are focusing here today to vision services, computer vision, and the face recognition. There are also other services like video analysis, content moderating, and custom vision. Custom vision is also an interesting thing because you can practically train computer vision services to recognize your own objects. Although computer vision sounds like something simple, I mean, well, is it hard to see? It's actually way more complex than we want to imagine. These 6 steps here practically give some idea what's happening behind computer vision. Okay, first step is, I think, pretty basic and elementary. We get the image from somewhere. Next, before starting analysis, we need to make some pre-processing to get better quality, to remove noise, and so on. So we have to prepare image for analysis. After this, we can start the first phase. With the first phase of analysis, we can start shaping out where are those interesting objects or areas on an image. So then we have to step by step go on and find out the areas where we probably have objects we know, and in the end we have to make decision. Is this area on an image, for example, is it dog or is it wolf? Perhaps we cannot make even an accurate decision. We can make a decision like with a 70% it's dog, and with a 30% accuracy it's a wolf instead. So it's very possible that the end decision is not just one thing, but it may be list of things with probabilities. So as you can understand, this kind of processing is resource extensive, and this is why it is also delivered by Azure as a service that is running in Microsoft Cloud. If we want to use it in a big scale, then hosting it by our own mean that we need to buy a lot of servers. Okay, now let's get our hands dirty, I think. Let's start with the face recognition. To my students, I always want to make things easy to understand. So as I'm teaching those who are pre-college ones, then I cannot explain them solutions like I can explain to you. If I say something, I have to explain what it is. And it's the easiest thing to do is to go step by step. I organized them a little boot camp based on these vision services. And I also let them play with face recognition. But to make them understand what it is, it was my first question. So, is this face recognition? So we find some head-like shape. Let's see if there is eyes, nose, and mouth. And we say, okay, we have a face. Is it so easy or is it more difficult? Okay, in practice, we have something totally different. As we can see, we don't get away so easily that we just detect some roundy shape and say this is head. We have different shapes of head, different haircuts. Some ladies are with scarves, some dudes have beards. So also people have different color of skin. Some have sunglasses, as you can see, and face recognition services have to consider all those little aspects. So otherwise, it would end up with a service that detects just a few faces and leaves out a bunch of other faces. And this way, I think the service would be not very good. So now let's jump to code. I have here one demo application. And now let's ask, what is a face for a computer? Is it an image somewhere, or is it something else? So, as you see, we can upload images to Azure Cognitive Services, and sometimes people hope, okay, is this some kind of a photo storage? I mean, perhaps gigabytes of storage where I can put my files, but I say, okay, I'm just recognizing faces. Now, I have to break these beautiful dreams, and let's see. What is face for machine? I think there are more about faces, but basically these services recognize people or faces by using spatial points called face landmarks. So, as you can see, eyes, eyebrows, nose, lips are covered with these red dots. This is how computers know and if needed, remember our faces. I'm sure there are more parameters besides these points, but actually our faces in computer vision world are just some numerical parameters. So, and cognitive services is not, unfortunately, another cool Instagram. Now I take a photo and I let detect faces on it. So, okay. We got here 4 faces. As you can see, then one face in a red square, it is a human being from a photo, and we have 3 other faces, and these came from a poster behind the little girl. Now, take a look at the top right corner of a poster. There is also one face, but for some reason this face wasn't recognized. Top left face also has some color above eyes, same way, but the right one didn't went through for some reason. Actually, as I found out, this face recognition is pretty sensitive to bad tricks like too much cosmetics and so on. I tried also with some extreme cases. If you take a stage photos, by example, from artists like King Diamond, Marilyn Manson, Kiss, Cradle of Filth, and the bands like this, where they have a lot of paint on the face. This service was able to recognize only 0 faces from these photos. Also, as a human beings, when we are taking a look at the King Diamond photo, we can say that here is one person for sure. Yeah, but from face recognition, it didn't went through. So, but it's now it was an easy example. Okay, just let's find the faces from a photo. Now let's make a little step further, and let's see. Let's see the same photo, and let's see what are emotions of people. So, in front, the little girl seems to be neutral. It's actually, those of you who are parents can understand that this face is not neutral. The face came 10 seconds after the news that we have to leave the playground. This face is in no way neutral, okay? But the other faces here, the green, okay, we can say, yeah, it is neutral. And also the face here in a red square, and the orange square, okay, with the highest probability, she is happy for a service. These numbers are actually probabilities. So if you are, if you multiply these numbers by 100, then you get a nice percent representation of these numbers. Okay, so now why this kind of thing like detecting emotions is important. Already today, some companies are building solutions for retail sector, where emotions analysis is used hand in hand with customer advising. So suppose you have some digital agent that is guiding customer, and now to tune advices that a digital assistant is giving. Customer emotions are continuously detected to understand if one or another advice is confusing or let's say out of topic. And this is one way how to without annoy your customers with questionnaires or feedback papers. It's a very effective way how to improve the information that helps them to make decisions. But now let's see what else we can find out about people. So I take here another set of data. It's called face attributes. By this set of data, we get another bunch of information. There's more information, and some numbers are even better split out than shown here. But still, this table gives you a pretty good idea what is possible to find out about images. But let's dig deeper a little bit. Not all data here is accurate. By example, on this photo, on the left side, there's me, but I'm not 53 years old yet. And before you show this cool tech at home to your girlfriend, this is advice for guys. Before you show it, okay, look, I found a cool tech, then please make sure that your girlfriend age is recognized well, or at least she's slightly younger. This algorithm is improved over time. First time when I tried, then it turned out that my girlfriend was 57 years old. So it's a mistake by 2 decades, and I think it's a too big number to present it at home. Of course, we know very well what to do as a developers. Easiest thing. How it was, girls were always happy to be 20, was it 28? Oh, yeah, so that's nice. So, okay, but this kind of information can also be used very practically. Suppose you have a security camera at home. This is now something that also must comply with the local laws if you want to use information that camera gathers. In some countries, there is a simple rule. If you use a surveillance camera, then you must have signs out. If you don't have these warnings and you want to use video filmed by camera, then it doesn't hold in a court. So make sure you know the laws. But now imagine you have some surveillance system for your home, and somebody breaks in your home or steals something, and you have a video, but you also have a photo. So if you got the person to photo, it's pretty easy to use these face attributes query and describe how this dude looked like. So we can actually use these persons here to even automatically create a description. Okay, guy with a big beard, around let's say 47-year-old, 20% bald, and so on. So, but by the idea, we probably should be able to get based on photo to automatically create the description that we can just spread out in our neighborhood or to send to police, and actually we can automate it. Now, besides these little simpler services, there's something more complex in a set of Vision API. Now, it is possible to identify people. Identifying means that we have to, we can introduce people to vision services, and later we can use this information to detect who is who on the photos we are uploading. It's a pretty good solution to use if we have, for example, let's say we have family photos. There are always, people who are repeating from photo to photo. If we are taking, by example, photos from previous eras, 70s, 60s, 80s, when we didn't have the internet, people met with each other in real life. For younger guys to know, visiting mom meant that you went to mom's home, said hello, communicated, not through a mobile phone, but in real life. So yeah, we lived weird lives. So, but from these times, I remember my family has a bunch of photos where from birthdays, some photos from funerals too, summer trips and so on. And as meeting each other in real life was practically the only normal way how to communicate. Then actually birthdays were not just 5 people, but usually around 20 and so on. So now if we introduce our family to a computer vision service, and we take these photos, there are many people, then it's pretty easy for us to let this service to recognize who's who on the photo, and also to draw out where one or another people on a photo is located. So Azure Face API has for this the term person group. Person groups are, let's say, like a top-level container how to organize people we want to identify to different groups. Inside the groups, we had photos of we add people, and for every people we can add photos. So these photos are analyzed by cognitive services. It's important thing because based on these analyses, the algorithms are calibrated better to recognize faces on the photos. Sometimes people have asked me the question, okay, but suppose we have some database with people, and we somehow want to have a link between our database and the photos in or people in the cognitive services. How can we do it? Well, the simple thing to do is to use a spatial custom user data field in a cognitive services to maintain link with the database. So now I show you how it works. So let's open here person groups. So here we can create different groups. I have here a group called My Family. And okay, here you can see this user data field. It is just some, for cognitive services, it's just some kind of random data. This data has meaning for you, not for this cognitive services side. So if you have a link with a database, then by example, you can keep user ID here in this user data field to keep a link. So and for people we can add faces, practically the photos where one or another person is well seen. So here, please don't add any group photos because it's confusing for a service, you can be sure. So, and after adding all the photos, it's time to train the user group. Training means that after adding new photos, the photos are analyzed and all these calibration parameters used to detect those people are improved. So training. Actually, as I have a small, small person group here, the training went pretty fast, but it's possible that it takes a little longer. So in our case, we got it done with 1 second, but it may take also let's say 20 seconds, 30 seconds, something like this. Now, how it looks on if we take some person group. So I specified here when uploading a photo that go and find these people on a photo from My Family group. So and here in the first column you can see it was able to detect all three of us. So, but it didn't detect any guys who are in the background. So now, if you ask what can be done in practice, well, around a year ago, Chinese government shocked practically the whole world when they came out with the news that they were able to spot one fugitive among the crowd of 60,000 people visiting a live show, and they were using their own CCTV and face recognition solution. So actually, these solutions can be, as you can imagine, very powerful. So, but it's also possible that we can make our lives easier. I know some user groups, technical user groups, are using this type of identification to automatically register attendees at their community evenings. So it's very easy and convenient. And also it's, as I told, if you have these old era photos you want to scan and keep in computer, then it's this is very valuable service. You just add photo by photo and you get all the faces on the photos. So here these rectangles here, it is not part of cognitive services. It's my own hack that these rectangles are drawn there. It's actually possible to do things the way that you, with a photo, you save, by example, the location of a rectangle by using %. So it doesn't matter how big is a photo on the screen. You can always, for example, using JavaScript, you can draw rectangles on a photo to correct place. I have tried this with my students, and it wasn't hard to do. For them, it was a little bit challenging to get JavaScript this far that it is drawing rectangles correctly. So, but it is possible to do. So in this case, you can do something like Facebook is doing. So you drag mouse on a photo, and then rectangle comes, and the name is shown near a picture. Okay, now let's see what's more we have here in the computer vision side. There is now one service that is for describing and tagging images. So I take one photo. Let's take one bridge. It's a Bratislava UFO bridge. So and this service is trying to give us some information about what's on photo. Of course, we can all agree it's not adult content, and probably there's nothing racy also with a bridge. But here you can see automatically generated description. As there are not many famous landmarks yet available in cognitive services, then it doesn't know that it is a UFO bridge in Bratislava. But still, it is giving us some kind of description. So, meaning that our photo doesn't necessarily have to have a title like DC 0856 or the name that photo cameras sometimes use. So, and we get also tags. So these tags are also generated by analysis of photo. As you can see, these tags actually are pretty accurate. So yes, it's outer photo, sky is here, water. So this water is also recognized as a river. I don't know why water and river must be here together. The river is also water, but okay. Where it got the idea that it is traveling, I'm not very much sure. Because if you live, by example, if you happen to live in Bratislava, then you are not traveling. I'm very much sure. So you see, you can make every day this photo if you like. Okay, yes, it is bridge. It's possible to also say it's a city because of these panel houses behind the bridge. And yes, we can say it's park. So tagging is pretty accurate. Description sometimes seems to me like well, I can say same thing when I look at the photo, but still it's good to have a service like this, and I'm sure that when data available on a cloud side gets better and better, then these descriptions will also improve over time. Now, there is also text recognition available. I understand that it is the main goal is to recognize text from different photos. I'm not sure if today office assistants anymore have a trouble like we got the fax and we want to get it now to computer as a document, and we have a scanner and OCR program and so on. I think this time is probably over. At least in Estonia, fax machine is something we are showing to kids and said, look, when daddy was young. So, but in most of offices, we don't have these kind of things anymore. So, but let's see how we can recognize a printed text. So, this is a column of text from some random magazine. And here is shown how and what this computer vision service now extracted out. With a printed text, it is a pretty accurate, but we already got here something weird. Okay, you can see here is lightning is reflected back, and this is what confused the algorithm. And another difficulty that this service has is if you take some tin can, by example. I had a real scenario because I wanted I had a tin can of malt extract from Poland. So, and I wanted to get the text from a photo of this tin can to lay it through Google Translate to understand the guidance how to make to turn this extract into nice beer. So, but then it turned out that yeah, I got the best matches I got from middle part of photo, but where a tin can was like turning, so left and the right edge, the text was actually visible, and I was able to read it, but this service wasn't very well able to detect it. So there is room for improvement. I show you another thing where we are pushing over the limits. So this is a nice photo I made in Krakow, and I thought it's pretty good test material. So. So if you take a look at here, then what now a service detected is far from perfect. So, and and what's the most interesting part? The big letter we all read, dead people. It wasn't recognized. So read dead was recognized this way. So elite speak. So it's it's still possible to find the easy ways how to confuse the service, but I also think it's something that will be improved over time. Now the same service can also recognize handwriting. Now if you think that it helps you to understand what the doctor wrote on receipt. No, it's not so powerful yet. So, okay, I take simple and readable handwriting. Let's see if it manages. Okay, so, okay, it was able to detect all the words here. But it's also easy to push handwriting recognition to limits. I tried the same service out with a photo of original handwriting by Shakespeare. It's a bad test material because it's in old time English language. So, well, it recognized just parts of words randomly. So, if handwriting is okay, then it is yes. Then this service gets done with a recognition. If you have a handwriting like doctors and lawyers have, then this service unfortunately can't help you. Okay, now I show you something I did with my kids at school. So to learn patterns, ASP.NET and things like this, I built with them a simple photo gallery. And these are pre-college kids. I cannot go and scare them with all kind of patterns we all know like this. So I had to make things easy enough for them so they don't get stuck, but move on. Okay, but I let them use these vision services, and I introduced them command pattern. So I didn't want them to build a huge method for saving image, and then add there all these calls to face API and other vision computer vision services. So we built commands, and then we built a composite command. So actually this is kind of a command that is running subcommands. And after a bootcamp week, we had a image gallery where that is able to detect GPS coordinates, use these Vision API services, and so on. So I run this application we built, and I add here a photo. So okay, I take the same photo here and save. Let's see what happens. Now it makes multiple calls, and then okay, and here we go. Below the photo, description is provided by describe image. We saw just a few moments before. There's no text to recognize for service, although there is some text is behind the leftmost tent, as you can see, but for some reason it didn't found it. But handwriting found out that we have something like this written on a photo. It was somewhere here when I let the rectangle around it. So it detected faces on a photo and also provided the tags. So all this happened practically with a one shot when image was saved. I show you. Okay, so this is how our image saving was built. So first, find out if we have GPS coordinates, then describe and tag using computer vision, then detect printed text, then detect handwriting, then detect faces, save image to file storage, save image to database. Using these APIs was simple enough for pre-college kids, so they were able to get these functionalities to their photo galleries with not much additional help. There were, yes, some points where I had to help them, but still it wasn't something very hard. It all came down more like a questions that okay, how should I handle one or another situation and so on. One tricky thing I show you. Okay, when we this is now how text recognition works. So we get most of information, whatever we are doing with just one API call. So there is one exception. I think Microsoft is still trying to improve handwriting recognition up to level of doctors, because when it is handwritten text, then the pattern is totally different. When they try to make it a little bit smaller, okay, it works the way that first we start handwriting recognition operation, and then we have to poll the service and ask, okay, what is your current status? So if it failed, okay, then there's nothing more to do. If it is proceeding, then we just have to wait. And when it once done, then we can ask back. Then we can ask with the same call all the handwriting results. So, but this is this far the only service in this family where I saw that we need this kind of pattern. All other services go like here with just a one shot. Okay. Now. Okay. Now, I'm almost in the end of this presentation. As you saw, these computer vision services that are coming are here and also they are still coming, are pretty powerful already today, and different sectors are already using or considering using of these services. Of course, on whatever solutions you work, you can always think about what are the possible use cases for these services in a context where you are working. Is there anything useful you can do? Is there anything you can automate, by example, or make life easier for your customers or end users? These services are not available only for a .NET platform. Currently, there are also libraries available for other platforms, and if platform where you are working is not yet supported, then like with most of Azure services, you can use REST endpoints. There are always REST APIs, and perhaps it's not always so easy to use these REST endpoints directly than to go with Microsoft provided APIs, but still using REST you can do it. Okay, this is all by me. Thank you for coming to my presentation. Yes, and yes, you may have ask questions too. Yes.
Is there a way to, for example, for handwriting recognition, for example, if I have an application which some part of this picture there is the handwrites, I can send this information to the API, get the results, and if the results are not correct, let's say the user will train the model with the correct text. Is there a way to train back the system, or it's not available?
The question is that if it is possible to train handwriting recognition.
Yes.
Currently, there is no way for this, as far as I know. At least I didn't found anything for this. So I think it's more like the way that this handwriting recognition is improved on the cloud side, without users getting directly involved. Yes.
Yeah, the facial recognition for your family, for instance.
Yeah.
How many photos does it take to really recognize the person? One or more?
I used per face 3 photos.
Really?
3 photos, yes. Yeah. Actually, the more photos you have, the better. But I think if you have, let's say, 5 photos, you see it's enough in a light of the photos you are analyzing. Then you can keep it on a 5. You don't have to necessarily go to 10. But again, if you have photos with different quality, different places, and so on, then it's possible. You just have to feed it very different photos of the same person, so they are able to better calibrate their algorithms and parameters. Yes.
So, related to the previous question, so it means that the model is not really doing a calculation, but already there is an existing model, and that model is adjusted to your family using those 3 photos.
You mean? Do you mean about the calibration?
Yes.
No.
I'm a bit surprised that you only use the 3 photos to detect face. So I expect that there is one model that is trained beforehand with really big amount of data, and that model is adapted to especially for your family using those 3 photos.
Well, per one family member, I used 3 photos per one member. Yeah, but
Still, it's not that much.
it's not that much, yes. But I had also nice photos. Nice photos. I didn't have those low quality photos made on the run with low end mobile phone. So, in this means I was in a good situation, you know. But it is yes possible that again that if we have photos with perhaps lower quality or photos made in the dark and so on, then this set of 3 photos per person is not enough. Yeah. So yes, but for these photos here and the similar photos made in the daylight. Photos with a pretty good quality, 3 photos per person was enough. Yeah. Okay. More questions? Anybody? No? Okay, but then let's finish here and thank you again.